Okay, students, I've been asked to make a video on the law of signs, especially the ambiguous case. So I'm going to be getting to this screen in just a second here, explain the screen. But before we do that, I want to go over the law of signs. Okay, let's study this picture. Notice I have this triangle right here, and I have angle A, B, C. And what I'm going to do is I'm going to just move the triangle around. When I move this vertex of the triangle, notice I'm changing all of these values except the measurement of the side of A. So again, here's little a, which is this side right here. Little c is right here. Here's angle A down at the bottom here, and here's this angle. Okay. So again, I could move another, I can move another letter here. Okay, and you see all the values change. Now my question is the ratio of the side to the sine of its opposite angle the same for each part of the triangle? That's a very good question. Let's see. Now I've asked a computer to actually compute C over the sine of angle C and A over the sine of angle A. Now I'm going to go back and I'm going to move my triangle. Okay, and if you notice, all of the values are changing. But down at the bottom, even though the values are changing at the bottom, the values are the same. So the ratios of the side to the sine of its opposite angle remain the same for a triangle. Let's see if it would work for a right angle. Okay, this is a very interesting situation here. Here I have it posed as a right angle. Okay, all right, so exciting, very interesting illustration of the law of signs. It works for sure, and that's exciting. Okay, now back to the ambiguous case. There are some times that we have to make sure how many triangles can be formed from the information we're given or from a picture with values. So notice over here I've got my angle A, okay, and this is a ray. So in other words, this line at the bottom, which is a side, I don't really know where this side of the triangle is yet, and you'll see why in a minute here, okay? But also notice I have side B, this is side B. I have side A, I'm just sort of leaving hanging, and then I have H, okay? So this is my setup, and notice I'm measuring here. I'm measuring the side, the length of H and A. All right, now let's go through the major criteria. First of all, let's see. Okay, notice in this case here that I have A is less than H. And I'm going to take this first of all, A is less than H. It will never touch the bottom of my triangle here, so I can't form a triangle. If I can't form a triangle, then the triangles, my answer is no solution. Okay, now I have another case. In the next case, A is equal to H. So I'm going to drag my, remember this is my side A, okay? So it's showing me where I'm dragging it. So I'm going to drag it down through here, and it's just going to touch that spot one place. So the question is very simple. If A is equal to H, how many triangles do I have? And the answer is one triangle. Okay, now I'm going to change the length of A. Okay, I'm going to change the length of A. I'm going to make A greater than H, but I'm going to make it less than B. All right, so I'm just going to pick a nice easy number like 10. Now, what's going to happen if we swing A? Well, notice I'm crossing my bottom line there, and I'm crossing my bottom line here. What does that actually mean? What that means is when A is crossing the bottom line here, I have this triangle. Okay, so the triangle would be A, B, C. When I move my A over here and I have a point that, again, it's got a lie on this bottom line here, I have another triangle. It's a funny looking triangle, but it's a very skinny triangle. Here I have A, B, C as well. So just remember, when A is between H and B, you have two different triangles. Okay, for our last case, we're going to take A and we're going to make it longer still. Okay, so now I'm going to go and make A, right here, A at the bottom, greater than B. So I'm going to use, how about we just say maybe something like 12, okay? All right, now what's going to happen? Well, what's going to happen is when I try to move this side, okay, see, notice the points here. I can't form a triangle here, okay, but I can form a triangle right here in this location right here. So how many triangles do I have? I have triangle A, B, C. I only have one triangle, and remember, this side is longer. So that would be if A is greater than B, the answer is one triangle. I hope this explains to you how we do the law of signs when we have an ambiguous case. We have to figure out what H is. We have to set up our triangle and remember to compare A. Whenever A is what? Let's review that for a second. Whenever A is less than H, I have no triangle. No triangle. Whenever A is between H and B, then I have two triangles, okay, like here and here. And then when A is greater than B, greater than or equal to, I'm going to have this one triangle over here, okay? So I hope that makes sense. I hope that helps you out. That is the reason for me making this video. Now, look at the next one where we actually do the problem of the ambiguous case.